Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about the internal parts of the valve are generally considered to be the removable internal parts that are in direct contact with the fluid. These parts are the stem, packing if required, stem guide rings, plug, and seats. The shutter or plug and the seats are the ones in charge of controlling the flow, thanks to the variable passage orifice that they form when their relative position varies, and that also have the mission of closing the passage of the fluid. There are three main points involved in the selection of the shutter and seats. 1. Normal and special materials suitable for erosion, that is the wear produced by the fluid. 2. Flow characteristics as a function of the stroke. Normal or reduced size that allows obtaining various flow capacities of the valve with the same body size. The plug and seats are normally made of stainless steel because this material is highly resistant to corrosion and fluid erosion. Here we can see the standard and special materials used in plugs and seats. When fluid velocity is low, PVC, fluorocarbons, and other soft materials alone or reinforced with glass fibers or graphite can be used. Ceramic plugs and seats may be used on some valves. As there is no material resistant to corrosion of all fluids, it is necessary to use combined materials, and their choice will depend on the environment in which they will work. Here, we can see a guide to corrosion-resistant materials without being an exact recommendation, because the choice of a material depends on the service conditions, which can alter the resistance characteristics of the material. Therefore, when choosing a material, it must be subjected to experimental tests. Where corrosion-resistant material is expensive or unsuitable, lining materials such as plastics, fluorocarbons, elastomers, glass, lead, and tantalum can be used. But if the lining fails, the fluid will attack the base metal, and the valve will be punctured. Erosion occurs when high-velocity particles in the fluid collide with the surface of the valve material. These conditions are found in the vaporization of a liquid, also called flashing, with sand, mud, etc. The possible presence of phenomena of erosion due to the large number of fluids and the wide variety of service conditions currently found in the industry makes it necessary to select the type and material of the body and the obturator in order to resist it, in particular under extreme conditions of differential pressure and temperature. Thermoplastic materials are corrosion resistant against many chemical materials such as sulfuric acid, nitric acid, etc., and they have good dielectric characteristics from 0.9 to 1.18 kilovolts per meter with the ASTM D149 test. They do not resist mechanical vibrations, but are suitable for coating materials in conditions of vibration and corrosion. In terms of erosion, thermoplastic materials have twice the duration than metallic ones, in cases where the flow does not exceed 3 meters per second, and the size of the floating particles does not exceed 300 mesh. Mesh is the size of the separation sieve of solids defined by the number of meshes per linear inch. The abrasive wear per day for two thermoplastic materials compared to cast iron is what you can see on the screen. Here, we can see the resistance to erosion of different types of valves. And here, we can see that the double seat valve, subjected to a high differential pressure, has a high fluid leakage velocity when it is situated to the closed position, with which the effects of erosion are greater than in the single seat valve that almost has no leaks. Also, a contoured plug is more suitable than a V-shaped plug. This one distributes the fluid flow through one or two of the V-holes, while the first one does so around the periphery of the obturator. The angle valve is more favorable than the globe valve, since its body and obturator are not subject to such a high degree of variation in the path of the fluid fillets. The plug and the seat are the most affected by erosion. There are special materials that cover the obturator and the seat, or that completely form them, depending on the desired degree of protection. Here, we can see different special materials resistant to erosion, with the type of coating that is applied to them. The use of these materials requires compliance with differential pressure and temperature limits on the autorator and the seat. And these are the ones we can see on the screen. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adiós!